Hello students, greetings of the day. Today I am going to introduce you to a new topic, errors in measurement. It's a very interesting topic and you must have noticed that in last 3-4 years at least 2 to 3 questions do appear from this topic both in NEET and JEE exam. So if you learn it thoroughly, you can easily fetch at least 8 to 12 marks in your exam. So without delaying, let us get started.
Here comes the error. What is meaning of error? If literally we say in English, meaning of error is mistake. अगर हम कोई भी गलती करते हैं, that is called error. But in language of physics, error is something that is related to measurement. And here as it is written, error is difference between true value and measured value. Now what is true value? This is the actual value of physical quantity which is to be measured, and measured value is the value we get after measurement. So difference between these two values is called error. Now I am going to categorize the error, how it can be categorized. So if based on origin we categorize the error, it can be categorized in two ways. One is systematic error and other is random error. What is systematic error? Systematic error is when we get either only positive error or only negative error. Then it is called systematic error. Now what is positive or negative error? When measured value is more than the true value, that is called positive error. When it is less than the true value, that is called negative error. Right? Now this is random error. Random error is the measurement where we get both kinds of error. It can be positive as well as negative. Like in one measurement we got positive error and in the next we got negative error. This kind of error is called random error. Now I am going to explain what are the causes that is responsible for systematic error and for random error. So let us see first the systematic error. The first cause, zero error in instrument. What is zero error in instrument? You all must be familiar of the weighing machine that we found on railway stations. So when you have to check your weight with help of that weighing machine, and if originally it is not at 0, the pointer is not at 0, already it is showing 2 kg. So whenever you measure your weight, that will be your actual weight plus 2 kg. So this is a systematic error. If there is zero error in the instrument, that will introduce a systematic error in your measurement. The second reason can be human biasness. Now what is human biasness? If one has tendency to take the reading while standing on right side of meter or on left side of meter, so this kind of biasness will introduce a parallax error. This will produce a systematic kind of error because either it will be always from right side or always from left side. So this kind of error will be there, which is either positive or negative. The next reason can be fault in measurement technique. If there is fault in technique itself, then it will produce systematic error. Here we can take example. If a doctor says to check our temperature, so what we do, actually doctor wants to check the temperature that has to be temperature of blood circulation, but we check the temperature of upper surface of body, which always will be somewhat lesser than the inside temperature. So this is fault in measurement technique, which will produce always a positive or a negative error. So these are mainly the causes which can produce systematic error. Now let us come to random error. The most frequent cause of random error is carelessness. If we are not careful enough, then it will produce, measurement will produce some positive or negative. It can be anything. One time it can be positive, in the next reading it can be negative, and so on. So if carelessness is there while taking the readings, it will produce a random error. Next is fluctuation in environment. You can take example. If we have to take readings for an electrical experiment and the supply voltage is fluctuating, so it will produce a random error. But here for JEE or for NEET point of view, we are not interested in systematic error or random error, because mostly we have to deal with the numericals. If we categorize error on mathematical basis, then it can be categorized in 3 ways. One is absolute error, next is relative error, and third one is percentage error. Now let us come first to absolute error. What is absolute error? This is simply the difference between true value and measured value, and I have taken mod here, so always it has to be positive. Whatever value is greater, the lower value has to be subtracted from that one. So this is how absolute error is measured. This is simply the difference between true value and measured value. Now if in question true value is directly given, then you can use the value. Otherwise you have to take mean of all the observations, and that will serve as true value. So this is how absolute error is calculated. Can you tell what would be the unit of absolute error? That would be the same as that of physical quantity A. Let us come to relative error. Mathematically it is defined as mod of A0 minus An, that is the absolute error, divided by A0, which is true value. Now relative term has more significance than absolute term, and this is true for all kinds of example. We can take an example. If in a group of 50 students, 30 students have got more than 90%, and in another group of 100 students, again 30 students have secured more than 90%. So if we say in absolute terms, both have the same result, because in both the classes 30 students have secured more than 90%. But if we check at the relative value, of course the class which has only 50 students will be having better result, because 30 students have scored out of 50 students. So relative term has always more physical significance, and the same is with relative error. Let us now come to percentage error. Percentage error will be, already we have calculated the relative error, that is the fractional error, and then multiply this with 100 to get the value in percent. So this is how percentage error is calculated. Now can you tell what would be the unit of relative error and percentage error? It will be unitless and dimensionless, because here we can see that it is being divided by the same physical quantity, so it has to be unitless and dimensionless. This is how absolute error, relative error and percentage error are calculated mathematically. Let us see now with help of one illustration how do we calculate the values. In question it is given, we measure period of oscillation of a simple pendulum, and in successive measurements the readings are 2.63, 2.56, 2.42, 2.71 and 2.80 second. We have to calculate absolute error, relative error and percentage error all. Let us now first we have to check what is the value of true value. So A0 has to be taken, because here in the question directly true value is not provided. So we have to take mean of all the observations, that would be 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80, and this whole divided by how many observations are there? 5. So it has to be divided by 5 to get the mean value. If you calculate the value, it will come out as nearly equal to 2.62 second. So this is the true value. We got the true value. Now it is asking for absolute error. In all the observation, absolute error will be there, but it is asking absolute error for this whole measurement. So what we have to take? We have to actually write the mean of absolute error. So let us calculate each absolute error. So it will be for one reading 1, that is delta A1, that would be equal to mod of 2.62 minus the first reading, that is 2.63. Similarly delta A2, that would be 2.56 minus 2.62, and remember mod sign is there, so it has to be positive. Delta A3, 2.42 minus 2.62, delta A4, that is 2.71 minus 2.62, and last delta A5, which is 2.80 minus 2.62. If you write all these values, it would be 0.01. We are writing the values in second. Another one is 0.06. Next is 0.02, 0.09 and 0.18. This is all the absolute errors in individual readings. Now we have to write mean of these values. So it would be delta A mean. Now I am writing for all these 5 values. If you take the mean, the calculation will come out as 0.11 second. So this is absolute error in the given observation. Now come to its relative part. What is the relative error? So relative error will be, we have to write now delta A upon A naught, that is equal to 0.11 upon 2.62. Nearly it would be equal to 0.04, and if it is asking for percentage, simply write this multiplied with 100. That will come out as 4%. So this is how error is calculated when a number of observations are given. Now come to propagation of error. This is very important. What happens? Always it is not possible to measure the physical quantity that we are interested in. Sometimes its value directly cannot be measured. There is no scale meant for it. So what we do? We actually measure some different physical quantities and then calculate the desired physical quantity with help of the known formula. So here we can take example of simple pendulum. We have to know value of acceleration due to gravity at a given place. Then it can be done with the help of simple pendulum experiment, because we know time period is given by t is equal to 2 pi root under L by G. So G can be calculated with the help of measured time period and length of pendulum, and it will come out as 4 pi square L upon T square. So we can actually measure L, we can measure T, and then calculate the value of G with help of this formula. Correct? Now what? Because for each measurement, error has to be involved. So when we are measuring L, error will be there. When we are measuring T, error will be there. So how this error will be propagated from these measured values, which is length and time, to the calculated value G, that we are going to discuss in propagation of error. Understood? In some of the books it is written as combination of error, but the actual term should be propagation of error, because here error is propagating from these two measured values to the calculated value. So this should be known as propagation of error more correctly. Here I have taken an example of simple pendulum. For this calculation of propagation of error, there are some set of formulas. First is, if dependence is of the type like a physical quantity Z is there which depends on two other physical quantities as Z is equal to A plus or A minus B, then absolute error in Z would be equal to absolute error in A plus absolute error in B. Always remember, even if it is minus sign here, that is Z is equal to A minus B, then also absolute errors are to be added, because after calculation error has to be increased. It can never decrease. Calculation itself introduces error. So while calculating the error, never write minus sign. This is how absolute error is calculated when dependence is of addition or subtraction type. Second dependence, we can think Z is equal to A multiplied with B, or it can be A divided by B. In both the cases, for these two kinds of dependence, relative error in Z has to be equal to relative error in A plus relative error in B. Do remember, if dependence is of multiplication or division type, relative error is calculated, not the absolute error. So first you have to calculate relative error, and then with help of the formula you can of course write absolute error if it is needed. Correctly understood? Come to other dependence, it can be z is equal to a to the power n. Then again, relative error in z will be equal to power times relative error in a. I am going to explain all these three with help of different illustrations, but do remember, always absolute error is calculated if it is addition or subtraction, and relative errors are calculated when this is multiplication, division or power, right? And the same is for percentage error, because when we have written relative error, just multiply this with 100 to get percentage error. Got it? Just to strengthen the concept, let us take one illustration. It is asking for find the relative error in z if z is equal to a to the power 4, b to the power 1 by 3 upon c d to the power 3 by 2. Now, as just we have learned, it has to be delta z by z is equal to, now check for the power of a, that is 4. So 4 multiplied with relative error in a, delta a by a, plus power of b is 1 by 3. So 1 by 3 times delta b upon b. This c d to the power 3 by 2 is in denominator, but still we have to write plus here, because while calculating error, minus sign is not written at all. Delta c by c plus 3 by 2 times delta d by d. If you want to take numerical example, let us see one. In one question, this is given in NCERT. It is given that P is some physical quantity which depends on A, B and C, D as A cube, B square divided by root under C into D. And percentage errors are given. For A, it is given as 1%. For B, this is given as 3%. For C, this is 4%. And for D, it is 2%. So, with the help of above example, we can easily write delta P by P would be, now directly it is better to calculate percentage, because all the errors are given in terms of percentage. So, it would be 3 into, what is percentage error in A? 1%. So, 3 into 1% plus 2 into 3% plus power of C is 1 by 2. So, 1 by 2 into 4% plus 1 into 2. And you can write the calculated value. It would be 3 plus 6 plus 2 plus 2%. That comes out to be 13%. Got it? One more numerical is there, and this is very important because a number of times this kind of numerical has come in your exams. So let us see what this says. Period of oscillation of a simple pendulum is T is equal to 2 pi root under L by G. We all are familiar with this formula. Measured value of L is 20.0 centimeter, and this is given 1 millimeter accuracy. So it is actually value of delta L given, that is 1 millimeter. Try to write in centimeter, so that would be 0.1 centimeter. Now come to measured value of time, that is 90 seconds. Of course it is for 100 oscillation, and in it the error is 1 second, because resolution of wristwatch is 1 second. In later part I am going to discuss what is this resolution and what is the accuracy, right? So we will see later. I have written here L, delta L, T and delta T. Now just calculate the values for error in G. What it would be? First write the formula for G. G is 4 pi square L upon T square. While writing relative error, no need to write the numerical constant. So that would be equal to delta L by L plus twice delta T by T. Now if you substitute the values, it is delta L by L, that is given 0.1 upon 20. Now this is very crucial, because it is given here delta T by T, but this T is capital T, which is time period, and we all know time period is equal to measured time upon number of oscillation. So Directly, whether we can write value of this small delta t upon small t or not, this we have to check first. So I have written capital T, which is time period, is equal to measured time upon n. Now let us see. If you write delta t, that would be equal to delta t upon n. So if we write delta t upon t, that is relative error in time period, it will be equal to small delta t upon n divided by t, which is again small t upon n. N got cancelled and we got small delta t upon small t. What is this? This is relative error in measured time. So do remember this. There is no need to consider for number of oscillations given while calculating relative error, right? And you will get a number of questions based on this concept. So always you can ignore this number of oscillation while calculating relative error. Of course, for calculating absolute error, it has to be considered. And here we are calculating relative error, so there is no need. 0.1 by 22 into, now directly we can write value of delta t by t, which is 1 upon 90. If you solve the values, you will get 0.027. So this is relative error in calculation of G. If it is asking for percentage error, that would be 0.027 into 100. So nearly it would be equal to 2.7%. Now you can practice a number of questions based on calculation of error. One more illustration I am taking. Here mass is given, there radius is given and length is given. These values are given for a wire. So we have to calculate percentage error in measurement of its density. Now what is density term? If we denote density by rho, that would be given as mass upon volume. This is volume. Now wire has a cylindrical shape, so it has to be pi r square L. Now apply the formula for calculation of density. It has to be relative density delta rho by rho, that would be equal to delta m upon m plus 2 times delta r by r plus delta L by L. All the values are provided here. This term which is written as plus minus, it is actually the delta m. This one is delta r. This is delta L. This plus minus shows the uncertainty. Measured value can be more than or less than by this much amount. So it is written as plus minus. Now substitute the values here. It would be 0.003 upon 0.3 plus 2 times 0.005 upon 0.5 plus 0.06 upon 6. If you write the values, it would be 0.01 plus 0.02 plus 0.01, that is 0.04. And if it asks for percentage error, then has to be multiplied with 100. So in percentage it would be 0.04 into 100, that is 4%. Now check out your option, that is option number 4. As you can see, this question has already come in JEE. Now come to the next thing. Is it possible that dependence of a physical quantity on other quantities be always as addition, subtraction, multiplication or division type? Isn't it possible to have some different kind of dependence? Now I am going to take one example where this standard formula which not be valid. So let us see how to calculate error if some different kind of expression is given. It is saying that two resistors are there. One resistor is having value 100 plus minus 3 ohm. Another resistance is 200 plus minus 4 ohm. It is saying that these two resistances are first being connected in series and then in parallel. And we have to check what would be the equivalent resistance. So let us see how is this calculated. For series, this is very easy because as we know, in series combination, equivalent resistance is given as R1 plus R2. This falls under the standard formula for calculation of absolute error. So directly we can write delta R equivalent would be delta R1 plus delta R2, that is equal to 3 plus 4, which is 7 ohm. And so equivalent resistance can be written as 100 plus 200, 300 plus minus 7 ohm. It is very easy to calculate. But come to the next part. Here R equivalent in parallel combination is written as 1 upon R equivalent is equal to 1 by R1 plus 1 by R2. So we cannot apply any standard formula here. How to calculate error then? See, error is always calculated with the help of differentiation. Even if we are using the standard formula that has derived with help of differentiation only. So let us differentiate the whole expression. What it would be? Minus delta Req upon R equivalent square is equal to minus delta R1 upon R1 square minus delta R2 upon R2 square. I have written delta in place of D here because for error the standard notation is in terms of delta. So I have written it like this. Now simply substitute the values that would give you all these minus signs can be cancelled. Delta R equivalent upon R equivalent square is equal to what is delta R1? 3 upon R1 square 100 and square of this plus delta R2 is 4 upon square of 200. Here in the rough work you can calculate value of R equivalent with help of given formula or write it simply R1 R2 upon R1 plus R2. So it will be 200 into 100 upon 300. That comes out to be 200 upon 3. Substitute this value here to calculate delta R equivalent. So it would be square of 200 by 3. Then this is 3 upon square of 100 plus 4 upon square of 200. After calculation, this will come out as 1.8. And finally, R equivalent can be written as 66.7, that is the solved value of 200 by 3 plus minus 1.8 ohm. Now you have seen how error is calculated if the given expression does not fall under a standard dependence provided in the formula. We have to simply differentiate the whole term. Any kind of expression you can solve with help of this method. And you can see in last 4-5 years so many questions are coming from this calculation of error. So it is very important from your NEET or JEE point of view. Never skip this topic. This is very important. Again I am telling you, never do commit a mistake. Always practice these questions a number of times, so then you would be able to solve any question that comes in your exam. Okay, bye.